So this is Precalculus, the triangle quiz review. So we're going to look at a possible ambiguous triangle. Okay, so in class we looked at, we were given a side of 27, another side of 12, and an angle 17 degrees between them. Okay, so we connect this other side here, right? We labeled it J, K, and F. Right? And then this is little k, little f, and little j. And we were looking to solve the triangle. Okay, solving the triangle we know means we want to find angle j, angle k, angle f, right? And we want to find side j, side k, and side f. And we're given, so I'm just going to put what we're given. We're given angle J is 17 degrees, side K is 27, and side F is 12. Okay, so what we did first was let me look at this. Okay, we used the law of cosines, right, to find side J. So we know J squared is equal to the other two sides squared, f squared plus k squared minus 2fk cosine of angle j. Okay, so we plug these in. We had f was 12 squared plus 27 squared minus 2 times 12 times 27 times cosine of 17 degrees. Okay, we plug that in and we get, let's just do it really quickly. Okay, so we get 12 squared plus 27 squared minus 2 times 12 times 27 times cosine of 17 degrees. Okay. Put that in our calculator, we get approximately 253.3145181, right? So we square root that to get j. Okay, so we got, that was j squared. So j is approximately 15.9158 whatever, or we could say 15.92. Okay, so we got that. We could write that here, 15.92 units. Okay, and we were on our way to solve this. So then we used the law of cosines to find angle k. Remember that we this time we said k squared equals to j squared plus f squared minus 2jf cosine of angle k, right? We subtract j squared and f squared from both sides, and we get k squared minus j squared minus f squared equals to negative 2jf cosine k. Divide both sides by negative 2jf, right? And we get k squared minus j squared minus f squared divided by negative 2jf equals to cosine of angle k. To get k, we now are going to unwrap cosine with the inverse cosine. Let's do that to both sides. The inverse cosine and cosine, they cancel each other out. We get angle k is equal to the inverse cosine of k squared minus j squared minus f squared over negative 2jf. Okay, so now let's plug in our values. Okay, so let's plug this into our calculator. We get the inverse cosine of k squared. K squared is 27 squared minus j squared is 15.92 squared minus f squared minus 12 squared divided by negative 2 times J, which is 15.92, times F, which is 12. Okay? So we plug that in our calculator, we get K, angle K is approximately 150.20 degrees. Okay, rounding at this point, this 9 makes it a 0 and a 2. So we wrote that up here, 150.20. We use the fact that if we add up all three angles in our triangle, right, we add them all up, we get 180. So 180 minus 17 minus 150.20 gives us angle K. So that's approximately 12.8 degrees, right? Okay, so we were okay with this. And then we were like, well, we could do this easier if we looked at the law of sines before we found angle K and angle F. If we use the law of sines, so law of sines was we're going to look at sine of angle J over little j is equal to sine of angle K over little k. Okay, so remember the law of sines is just looking at J and J and K and K, wherever that is in our triangle. It's looking at this ratio, this angle to this side and this angle to this side, right? So we plugged in angle J, so sine of 17 degrees over 15.92 is equal to sine of angle K over 27, right? Getting the values from here. So I multiply both sides by 27. These cancel out, and I'm left with 27 times sine of 17 degrees over 15.92 is equal to sine K. Okay. So if I want to get K alone, I have to do the inverse sine of both sides, right? So let's do that. The inverse sine of 27 times sine of 17 divided by 15.92. And I get K approximately 29.73 degrees. Okay, so what's going on? This does not match this right here, right? So what is going on? Why? Is this triangle ambiguous that we had at the beginning? We knew a side, an angle, and a side, right? So that is not ambiguous because side, angle, side theorem from geometry allows us to know that we can get one triangle defined by a side, the angle in between, and another side, right? So one of these answers is wrong. Okay, so which one is wrong? Is it this one or is it this one? Okay, so here's where we have to just use some, we have to step back and look at the problem. Okay, so this angle right here, angle K, right? We're given this one is 17 degrees, angle J, and angle K, it opens up to side of length 27. Angle J, well, we found J is equal to 15.92. Okay, so 17 degrees opens up to a side of 15.92. Well, we would expect this angle, since it's opening up to a side bigger than this one, right? This angle should be bigger than angle J. So is that true for both of them? Yes, that's true here. And yes, that's true over there. So they're both bigger, okay? So we're happy with that. But let's do a little more investigation. Okay. So if angle K, right, is 150 degrees, right? That means this angle here is obtuse, right? And that means this side and this side, right? If this is obtuse, the triangle can look like this. Okay. Now let's look over here. Well, if angle K is 29.73, then we have a triangle with J here is 17 degrees. Then this angle K cannot be obtuse. It would have to be kind of small, right? It wouldn't be able to be over 90 degrees, so it would have to close in right there. Okay, so that would be a little bit of a problem, maybe. Okay, right. So this one we kind of have to think about. Well, is that okay? Well, really, what we also can know, I think this is the tricky part, is that sine of x, the function sine of x, it repeats. Okay, so if you look here, right, it repeats, it oscillates up and down and repeats itself. So at 0 degrees, so if the x-axis is degrees, 0 is here, 180 degrees is here, 360 degrees is here, okay? So right in between there we have 90 degrees. 90 degrees. Okay, so 90 degrees we have the value of 1. Well, somewhere around here, right, we have 29.73 degrees. 29.73 degrees is going to give us this value, right? Well, someplace over here is also giving us the same output, okay? And that is going to be why we get this ambiguous answer using the law of sines. So let's look at this. So basically, any value when we take the sine of it, if we take the sine of 180 degrees minus that value, we get equivalent answers. Okay, that's a property of sine right there. So let's see if that works. So sine of 29.73 is equal to what? Let's bring out our calculator. Sine of 29.73 is equal to 0.4959, okay? So if we take sine of 180 degrees minus 29.73, what do we get? We get the same thing, okay? So what is 180 degrees minus 29.73? We plug that in, and we get 150.27. And what do you know? That is what we got up here approximately, right? We're looking at approximately. So by rounding and things, we get pretty much what we got when we use the law of cosines for our angle K if we're looking at equivalent measures of sine, okay? Because all the law of sine is saying is that sine of angle J over J is equal to sine of angle K over little k, right? So if K is 150.27, right, angle K or K equals to 150.27 degrees, okay? So if K, we get basically two possible answers from the law of sines. This K or this K. Well, this K we know gives us different values for angle F, okay? So we know for sure angle J is equal to 17 degrees, right? Because that's what we're given. Angle J is equal to 17 degrees. If angle K is 29.73, 180 minus 29.73, we get angle F equal to 150.27. Oh, we forgot to subtract minus 17. So angle F would be equal to 133.27. degrees. And if angle K is equal to 150, this is where we have the equivalent as we did it with using the law of cosines. We get 180 minus 150.27 minus 17, and we get angle F equal to 12.73 degrees. Okay, so even if we can get this far, we know that we have one of these two answers. Well, which one works in our triangle? Well, let's move away the calculator. Okay, we know that side K is the biggest, right? This side has to be the biggest, therefore the angle opposite it has to be the biggest angle as well. Okay, so if we're given side, so angle F being bigger than angle K is not what we want. Okay, we need angle K to be the biggest angle and angle F to be smaller and angle J to be smaller. So this is the correct answer, and we just have to know when we're using the law of sines to be careful that sine of an angle is equal to sine of 180 degrees minus that angle, minus the angle measurement. It's just the angle symbol. Okay, so sine of an angle equals the sine of 180 degrees minus the angle. Then we just have to kind of check, does that fit in with our reality? Okay, so this ends talking about the possible ambiguous triangle that we get from the law of sines versus the law of cosines.